Hello and welcome to Maths Table. In this lesson of coordinate geometry section 2.3, we are going to discuss what is the equation of a straight line, and we are going to solve some miscellaneous problems which will cover all the concepts of coordinate geometry. Now the equation of a straight line is simply a mathematical relationship between the two x and y coordinates of any point which lies on a particular line, such as for example we have one equation here, y is equal to x minus 2. The meaning of this equation is that if we substitute the value of x coordinate of any point, such as for example point A, and subtract 2 from it, we'll get the y coordinate of that same point A. And not just one point, but every point on that straight line which has this equation will satisfy the equation of that line. So the equation is a single relationship which actually represents all the points which lie on that straight line. Now to better understand this, we can take an example of a straight line graph which passes through 2 points P and Q with the coordinates given to us, and a third point which is basically called the y-intercept of this line, and it is the point where it crosses the y-axis. This point is commonly represented by a small letter c. Now, if we have to find the equation of this line, what we need to do is we need to find out few quantities, and there are numerous different ways of finding the equation and different forms of the equation of straight line. We'll discuss here only the important ones, such as this form, gradient-intercept form or slope-intercept form, is probably the most commonly used form to find out the straight line equation. Y is equal to mx plus c. Here, m and c are two constants which we need to know before we specify the equation. M, as we have discussed in our previous lesson 2.1, is the gradient of the straight line, whereas c, as we have discussed here, is the y-intercept of the line. If we know these two things, the equation is completely specified. Now, in this case, if we take this line and we are using this form to find out the equation, we can use this given information here, such as first we'll find the gradient of this line m by using these points P and Q. Now, as we know that the gradient formula is basically the ratio of rise to run, and rise is calculated by taking the difference of the y coordinates of the 2 points, whereas the run is calculated by taking the difference between the x coordinates. So putting these values here, 9 minus 5 over 4 minus 2, we get the final value of the gradient, which is 2. So now our equation becomes y is equal to 2x plus c. Now to find out c, what we can do is we can select any of these 2 points or any other point on the line and substitute the coordinates into this equation, such as if we take this point P, which has x coordinate 2 and y coordinate 5, we can put the relevant values in the equation, and hence we can calculate the value of c. Over here you can notice that in place of y we have written the y coordinate, and in place of x we have placed the x coordinate of the point P, and this 2 is the gradient which we have already calculated. So now we have both the unknown constants m and c, and hence we can write the final equation of this line y is equal to 2x plus 1. So this is one of the ways, in fact, one of the most commonly used ways to find out the equation of the straight line. However, we also have another way to find out the equation, which is using the point slope form of the equation. In the point slope form of the equation, we have to put one point of any of the points on this line, just like we did before, and we need to find the gradient of the point. So if we have calculated the gradient before, we can use the same value for m, and we can put the same point P into this formula, and after simplifying it, we'll get the same answer as before. So we can use either of these two methods based on the given information to find out the equation of any given straight line. Now, the third but less commonly used method to find out the equation is the intercept form of the equation. This is the method which we cannot use for this example, which is because for this we need to know both of the intercepts. Like here, we know that it is crossing the y-axis at this point, which is basically 1, but we don't know the x-coordinate or the x-intercept of that point where this line crosses the x-axis. But we'll discuss it in the coming example, how to use this form to find out the equation. So for now, we have calculated the equation of a straight line using the two most commonly used methods. One is the gradient or slope intercept form, and second, the point slope form. Now let's take a question here. A straight line crosses the x-axis at point A and the y-axis at point B with the coordinates shown in the figure. In the first part, we are required to find out the gradient of the line AB. Now we can use the gradient formula which we've discussed earlier, which is the ratio of rise to run, y to minus y1 or x to minus x1. And substituting the required coordinates into it, we get the gradient as 4 over 5. In the second part, we are required to find the equation of this line AB. Now, as we have already calculated the gradient, we can use this gradient-intercept form here, which is y is equal to mx plus c. Here, m is 4 over 5, and c, which is the y-intercept of the line, is clearly shown in the diagram, which is 8. So substituting the required values in their respective places, we get finally y is equal to 4 over 5x plus 8. Or if we further simplify it, we can get 5y minus 4x minus 40 equal to 0. So this is how we find the equation of line AB. We can also use the intercept form of the equation, which is x over x-intercept plus y over y-intercept equal to 1. This is because in this question, we know both of the intercepts of this line. So substituting the required values and simplifying it further, we get the same answer as we obtained with the gradient intercept form. Now in the next part, we are required to calculate the area of this triangle AOB. Now, as we know that the x and y axis intersect at right angles at the point of origin, therefore, we can say that triangle AOB is a right angle triangle. So in this way, if we take OA as the base of this right angle triangle, then OB will become the height of the triangle as they are perpendicular to each other. So using the formula for the area of triangle half into base into height and substituting the values of the length OA and OB into this, we get finally the area 40 square units. In the last part D, we are required to calculate the perpendicular distance from origin to the line AB. Now if we take AB as the base of the triangle, we know that the length which is perpendicular to AB, which in this case is the distance from O to AB h, this gives us the same area as we calculated before. This is because the area of triangle remains same regardless of the side which we choose as the base. So we can choose OB as the base, OA or AB as the base. So if we have chosen AB as the base, then h is the height of the triangle. And keeping the area constant, we can calculate the value of h. But first we need to find out the length of AB using the distance formula which we discussed in section 2.2. This comes out to be under root 164 units. Now substituting the value of AB and equating the area equal to the previous value, we get finally the value of h, which is 6.25 units. Now let's take another question here. In this question, we are given a diagram which consists of a rectangle APQR where the length AP is parallel to the x-axis and the 3 points A, B, and C which make up a triangle inside the rectangle are also given to us. Now, based on this information, we are first required to find the coordinates of these 3 points P, Q, and R. Now, just by looking at this scale diagram, we can clearly see that the x-coordinate of P is 6, whereas the y-coordinate of P is 4. So, the coordinates of P are 6 and 4, whereas the coordinates of Q are 6 and 7, whereas the coordinates of R are 3 and 7. So, just by looking at this figure, we can determine the coordinates of these 3 points. Now, in the second part, we are required to find the area of this rectangle APQR. Now, as we know that the area of a rectangle can be found out by taking the product of the two lengths, length and width, which in this case are AP and PQ. So we can simply calculate the lengths of these two sides from this given figure. We know that the AP length can be calculated by taking the difference between the x coordinates of A and P, which comes out to be 3 units, and the width of the rectangle PQ can be found out by taking the difference between the y coordinates of the points P and Q, which also comes out to be 3 units. So basically APQR is also a square. Now we can find out the area of this APQR by simply taking the product of these two lengths, which comes out to be 9 square units. Now in the final part, we are required to find the area of the triangle ABC. Now looking closely in this figure, we actually need to find out the area of the shaded part here. And we can also observe from this figure that this rectangle consists of three right-angled triangles, APB, BQC, and CRA, with the lengths, base, and heights, which can be calculated just the way we did before with AP and PQ. So we have all the lengths required to calculate the areas of these three unshaded triangles. And we can simply calculate the area of the shaded triangle ABC by subtracting the areas of these three unshaded triangles from the total area of the rectangle APQR, which we already calculated in the previous part. So simply using the formula for the area of triangles and substituting the required values, we can finally obtain the area of the triangle ABC as 7/2 square units. Now in the final question, we have an equation of a straight line 4y plus 2x plus 6 equal to 0. And in the first part A, we are required to calculate the gradient of this line. Now just by looking at this form of the equation, it's not possible to deduce the gradient directly. However, if we rearrange this equation into the gradient-intercept form, which was y is equal to mx plus c by making y the subject of the formula, then the coefficient of the x term will be the gradient of this line. So by rearranging this equation and dividing the entire equation by 4 and simplifying it, we finally get the coefficient of x as -1/2. So in this way, the gradient of the line can be found out by the equation as -1/2. Now in the second part, the coordinates of the point where the line crosses the y-axis need to be found out. In other words, they are basically asking to find the y-intercept of this line. And we know that at any point on the y-axis, the x-coordinate is 0. So that means the y-intercept from the equation can be clearly read, which is the constant being added to the mx term in the gradient-intercept form, which we have already here, -3/2. So in this way, the coordinates of the point where it crosses the y-axis are 0 and -3/2. In the third part, we are required to find out the coordinates of the point at which the line intersects the line y is equal to 3. Now, on the line y is equal to 3, every point has a y coordinate of 3. So if this line is meeting the line y is equal to 3 at any point, then that point will definitely have a y coordinate of 3. So we just need to find out the x coordinate of this point. So substituting the value of y is equal to 3 into the original equation and rearranging it, we finally get x equal to -9. So in this way, the coordinates of this point are -9, 3. Now in the final part, we are required to find the equation of the line which is parallel to this given line and which also passes through the point 4, 2. Now, as previously discussed in section 2.1, if two lines are parallel, then their gradients are equal to each other, which means that the gradient of this second line is equal to the gradient of the original line, which we already deduced in the previous part, -1/2. So we just need to find out the y-intercept of this second line, which can be easily done by substituting the point through which this line passes. So we'll put 4 in place of x and 2 in place of y, and by solving this equation, we get the y-intercept c equal to 4. So in this way, the final equation of the line can be written as y is equal to -1/2x plus 4, or by further simplifying it, we get 2y plus x minus 8 equal to 0. Now, in the end, we would like to thank you very much for your valuable time in watching this video. For any questions or queries, you are free to contact us directly on our Facebook page and on our Instagram. And for more updates, please subscribe to our YouTube channel. Thank you very much and have a nice day.